All right, guys. Good evening. Happy Thursday. Welcome back. We have completed sections 1 and 2 in regards to volume 1 of the CCNA 200-301 official Cert Guide Library. So we're going to go ahead and we're going to hop in and we're going to go ahead and start talking about Chapter 8, implementing Ethernet VLANs. Okay. And so some of the topics that we're going to go ahead and touch on in chapter um, that we're going to go ahead and touch on in Chapter 8 is Network Fundamentals 1.0. 1.13 describes switching concepts. 1.13.a, Mac Learning and Aging. B, Frame Switching. C, Frame Flooding. D, Mac Address Table. We're also going to cover 2.0 Network Access. 2.1 configure and verify VLANs in a normal range, spanning multiple switches. We're also going to go ahead and cover access ports. We're also going to go ahead and cover default VLAN, inter VLAN connectivity. We're also going to go ahead and cover configuring and verifying inter switch connectivity, trunk ports, 8.21q, and native VLAN. So just to go ahead and give you guys a precursor, because I looked at how much the material we have to cover, this is a long chapter. We will have to split up our theory discussion for chapter 8 into roughly 3 sessions. It will be an overload of information. So that's I want to break it up, give time for questions, and go from there. Okay. So with that being said, let's go ahead and get started. Right. So before we jump into VLANs, right, and I'm a big guy on fundamentals before hearing buzzwords or hearing the acronyms and not knowing what they mean. Before we can understand what a VLAN is, you have to understand the definition of a local area network. Okay, right? So local area network, right? Right? What is it? It is all devices within the same broadcast domain. Okay, right? So what is a broadcast domain? Same exact thing. The broadcast domain includes the set of all local area network connected devices, right? So why would we call it a broadcast domain? We call it a broadcast domain in regards to a local area network so that if a device on the local area network sends a broadcast frame, all devices in that local area network will get a copy of that frame. And we're saying frame, not packet, because we're talking about layer 2. Okay? All right. So this picture right here, right? We have two broadcast domains, right? Okay, don't worry about the amount of switches. I just want you to worry about the broadcast domain. We're not talking about VLANs yet. We just have two different broadcast domains. There's not a connection between the two switches. So one broadcast domain is here and one broadcast domain is there. This may be one subnet. This may be another subnet. Okay. All right. Let's go ahead and keep going. All right. So the thing is, right, if we go ahead and let's say we were to, if we use default settings, right, default settings on a switch, right, all ports on a switch is going to be in the same broadcast domain, right, aka they're going to be defaulted into VLAN 1. Okay. All right. So we understand that. I want to go ahead and level set. We understand that, right? So let's keep going, right? If we go ahead and use two VLANs, right? What can happen is now one switch, right, can have two broadcast domains. Okay? We can accomplish this same design that we have here, right? As far as splitting up the broadcast domains. Let's go up a slide, right? So this is what we see right here, right? So we see we only have one switch, but we went ahead and set up two VLANs, two broadcast domains, right? Two virtual local area networks. Okay, right? Virtual local area networks, meaning this was a local area network programmed by software. Okay, so we were able to achieve this, right? We created two broadcast domains using one switch by VLANs. All right, simple enough. Okay. So of course, this is the CCNA, but of course, you guys will have to understand the basics of design, right? Whenever you're designing, right, a local area network, right, that's has many different uses of host and devices, right? Design is going to be a big thing, right? Because the more hosts you have, the more a local area network is susceptible to broadcast frames, right? And broadcast frames can go ahead and overload the network if there's too much, right? Because it's getting sent to all devices, and they have to be processed using the law of unknown unicast broadcast that you guys learned in earlier chapters. Okay, so if we limit the number of hosts per VLAN, we can limit the amount of broadcast frames that can possibly be sent within the broadcast domain. Okay, let's talk about a couple of the reasons why choosing a smaller broadcast domain, aka VLAN, would help your design. Right, one, to reduce CPU overhead on each device, improving host performance by reducing the number of devices that receive each broadcast frame. That's what I just spoke about. Okay. Two, to reduce security risk by reducing the number of hosts that receive copies of frames that the switches flood, right? Broadcast, multicast, and unknown unicast. Okay. Three, to improve security for host through the application of different security policies per VLAN. Okay. Four, to create more flexible designs that group users by department or by groups that work together, right? Instead of by physical location. So let's say we have one building, right? And we have many devices. We have maybe IoT devices. We have wireless access points. Maybe we want a management network. Maybe we have servers, right? Maybe we have a sales department. We have an engineering department. We want to split all of them up, right? This is where that applies. Okay. Let's talk about number five, right? Number five, to solve problems more quickly, because the failure domain for many problems is the same set of devices, has those in the same broadcast domain. I'm going to repeat this. To solve problems more quickly, because the failure domain for many problems is the same set of devices, has those in the same broadcast domain. What does this mean? What this means, if I have a printer VLAN and there's issues with one printer or two printers not being able to reach out to maybe a cloud provider, right? To maybe report ink levels or what have you, right? I can go ahead, if I run through my troubleshooting methodology, right? Using that troubleshooting methodology that I learned from the CompTIA Plus, I can now isolate what I'm troubleshooting instead of going through the troubleshooting methodology 10,000 times of creating a theory. I know I designed this network, right, per VLAN, per purpose within my network. This is what it helps. Okay. You got to work smarter, not harder. Okay. Number six, to reduce the workload for the spanning tree protocol, STP, by limiting a VLAN to a single access switch. That's a big one. We haven't spoke about spanning tree. We'll do that in chapter 9, right? And we'll just talk about the concepts. We won't go deep into it. But guys, it is, again, design is a very huge thing. And spanning tree is something you have to understand. Whenever you're designing VLANs, multiple switches, within the same environment, you have to make sure that you plan properly your root switches, your designated switch, and your non-designated switch. We'll talk about that in the future. We'll talk about cost. We'll talk about all of that. But these are things, whenever you're implementing VLANs, that you have to consider. Okay? All right. So that was a quick, right? A quick, introduction of what we're going to talk about within this chapter, right? The rest of this chapter, we're going to go ahead and cover some of the mechanics, right, of a VLAN, right? That works across multiple Cisco switches. I have to make sure I say that. I'm going to go ahead and touch on, just like before, the required configuration on creating a VLAN, right? We're also going to talk about VLAN trunking. right? We're going to briefly, I have no slides on it, but we're going to briefly touch on VTP. I have confirmed that VTP, right, VLAN trunking protocol, is not, you will not be tested on that within the exam, okay? But it's good to know, it's good to understand, right? And understand how it works. Um, and it's a good technology if you want to use it when you first deploy an environment, and then of course turn it off after. All right. So let's go ahead and jump on in. Okay. So we spoke about creating multiple VLANs, right, on one single switch, right? Little to no effort, right? You go ahead and just, you configure the VLAN, you tell the ports on the switch, hey, I'm going to assign you to this VLAN, right? So that, of course, a port will be assigned to a broadcast domain, right? Now, if you start implementing multiple switches, right, you have to go ahead and consider additional concepts about how to forward traffic between switches. This is going to take a little bit of time, patience, and effort, okay? So if you're using VLANs, right, in networks that have multiple switches interconnected, right, the switches need to use trunking, right? Okay. Or the technical term VLAN trunking on links between switches. Okay. VLAN trunking, what it does, it causes the switches to use a process called VLAN tagging, by which the sending switch adds another header to the frame before, and we'll look at this in a packet capture whenever we do our lab. You're gonna see that tag right on each frame before it's sent out over the trunk, right? And so what it does, right? This extra header that's added, right? It's going to have the VLAN ID, aka the VLAN identifier, right? What is this for? So what this is for is that whenever switch one is sending traffic dedicated to VLAN 20 to switch two, the VLAN ID within the header is going to say, hey, this is dedicated for VLAN 20. Only send this out ports that are associated with the VLAN 20. Okay. All right. We're looking at 8-3. This is an example of what we're talking about, right? We have a switch, right? We have a switch. It has multiple VLANs. Both of them have multiple VLANs, but they're not trunking. They're not trunking. Okay, right? So if we look at it, right, we see that VLANs exist right on both switches, right? It doesn't use trunking, right? We got the VLAN 10, VLAN 20. Each switch has ports in each VLAN, right? In this design, it has links. It has links between the switches, right? One link that's inside VLAN 10, one link that's inside VLAN 20. Okay. But, right, we have to understand something. It does work, right? So, and here's what I mean by I say it works, right? PC11 can definitely send a frame to PC14, right? It's going to flow through switch one, right? Over the top link, right? And go ahead and knock that out, right? This is not a trunk, right? This is not a trunk. This is just a link, right? All it does, it requires one physical link between switches to support every VLAN, right? What happens whenever we do this, right? So we're passing traffic. This link goes down. Now PC21 can't communicate to PC24 because this link is only in VLAN 10, not this link. This doesn't scale well, right? Again, design is very important whenever you're implementing stuff, right? So let's go ahead and jump in and let's talk about what a optimal design would look like, right? So this is what it looks like whenever we have, switches, right? Two switches connected to each other, right? That have multiple VLANs that implement trunking, right? Once you implement trunking, it will support as many VLANs as you need. Because again, you are you getting the CCNA, you are the administrator, you are the associate that's in charge of the network, right? And whatever you need to configure, you can go ahead and configure it within your configuration. Okay. All right. So now that we have implemented trunking within that same link, right? Within the same link, VLANs 10 and VLANs 20 can traverse that same link, right? Okay. So imagine those two pipes that we saw earlier, they're bundled together. So even if this went down, VLANs 10 and VLANs 20 can still go over, right? The top link. Does that make sense? Okay. Very important, very cool thing about VLAN trunking. So now let's talk about tagging, right? So we spoke about earlier what the switch does whenever it's sending a frame out of that trunk, right? We see VLAN 10, VLAN 20, VLAN 20, VLAN 10, right? This is what it looks like as far as tagging. Think of these as frames, right? Each of those frames, right? Let's say it came from this PC, it's coming from VLAN 10. This is tagged for VLAN 10. So anything within VLAN 10, switch 2 is going to send it. Okay? Anything tagged for VLAN 20, it's going to send it to only those to VLAN 20. Okay? Simple enough. And that's the concept of VLAN tagging, right? Let me show you another graphic that shows it a little bit better. Okay? Exactly what I just stated, right? You see here, VLAN 10, right? Well, I'm sorry, VLAN 10 is sending this out. Step 1, step 2, and let me erase that and make this a little bit better, right? PC 11 sends it down to the switch. Switch 1 sends it out of gigabit Ethernet interface 0/1. We send it on the trunk. It is tagged right here for VLAN 10. So when switch 2 gets it, it's going to say, hey, only send it to host in VLAN 10. Okay? All right. And again, that's the concept of VLAN tagging. Okay? Now, how does trunking work? Right? Is it a specific protocol? Right? So Cisco has two trunking protocols. It has 802.1q and it has ISL. Okay? ISL stands for inter-switch link, right? 802.1q is an IEEE standard. So you'll see that across multiple vendors. ISL was created by Cisco, right? Years before 802.1q. Okay. But of course, you'll see in Juniper switches, you'll see in Aruba switches, most of them use 802.1q, has their trunking protocol. Okay. Now, both ISL, 802.1q, they do tag each frame. Okay. Let me get my handy dandy pencil. They both tag each frame if they're going over a trunk. Okay. The big difference here is that 802.1q, it inserts, right, an extra 4-byte, aka 12 bits, right? 4-byte 802.1q VLAN header. Okay, into the original frame's Ethernet header, right? Okay. And correction, 12 bits is not 4 bytes, by the way. So I apologize on that one. Reading my notes wrong. But yes, within this 4-byte header, it's 4 bytes right here, right? All of this is covered. Within this 12 bits will be the VLAN ID, and you can actually see that within Packet Tracer. Okay? Right? So that's what you guys will see. Within this 12-bit field, and I'm going to say this because it's going to make sense as far as how many VLANs you can configure on a switch. That 12-bit field that I just marked supports a theoretical maximum of 212. Okay? 212, aka 400 I'm sorry, 4,096 VLANs, right? But in practice, of course, it supports a maximum of 4,094. Okay. Um, because of course, two VLANs are dedicated to the switch. And we'll talk about that later. Okay. All right. Let's go ahead and clear this out. Okay. And I think this is some theory, what I'm about to explain to you, that you need to understand. Cisco switches, they go ahead and break the range of VLAN IDs, right? 1 through 4,094, right? The usable ranges, into two ranges, the normal range and the extended range. Okay, I'm going to say that again. Cisco switches break the range of VLAN IDs from 1,000 to 4,094 into two ranges. We have the normal range. Okay, that normal range is VLANs with values from VLAN 1 all the way up to 1,005. And then we have the extended range. That extended range, right, is VLAN IDs from 1,006 all the way to 4,094. Here's the thing. The rules for which switches can use the extended range, right? VLANs depend on the configuration of the VLAN trunking protocol, aka VTP, right? And we'll talk about that later. Okay. But I need you guys to understand that 1 through 1,005, normal VLAN range. 1,006 to 4,094 is the extended range. And for you to utilize the extended range, you have to manipulate it via configuration. Okay. All right. Let's keep going. Right. Within, of course, 802.1q, right? There's also one VLAN ID on each trunk that needs to be defined. That is the native VLAN, right? By default, Cisco switches use VLAN 1, unless it's configured differently by you, right? But by default, if you don't tell it if you don't define what the native VLAN is, the native VLAN for a trunk will always be VLAN 1. Okay? All right. The rules for for trunking, right? The native VLAN has to match on both switches. If you have a native VLAN mismatch, traffic will not pass. Okay. All right. Let's go ahead and let's keep going. Well, you know what? Let's go ahead and stop here because this is going to go into another section. Let's stop here, and I want to open the floor for questions. Because again, this is where we're getting to the nitty gritty as far as VLAN. I'm sorry, until layer 2, and layer 2 is a big precursor for layer 3. So please ask all the questions.
Good evening, Dave. Hope you're
What's up,
doing
buddy?
good.
Doing
Hey,
good.
good. Thanks for delivering this lecture here today. It was very good. I do like to go back where frame actually goes, initiates from a computer and make it its first round to the first switch, and then it crosses exactly this one. So my question is, when the PC sends out a frame, is it untagged, and then the switch puts the tag for the frame?
Absolutely.
Okay.
Absolutely. Right? Because there's no way to configure a VLAN on a PC. You probably can, but by default, right? If a regular end user within an enterprise just plugs in their PC into a switch port, no end user is gonna, by default, normal end user is not gonna have a VLAN configured on their PC. So that VLAN is configured on the port of the switch. When frames are leaving the PC and it's entering, right? The switch, it enters the switch. The switch says, okay, this port is a part of this specific VLAN.
Exactly.
If it needs to go over a trunk, right? If it needs to go, if this is dedicated for something within its broadcast domain, if this broadcast domain, aka VLAN, exists within the trunk, I'm going to go ahead and forward that traffic and make sure I tag it, as long as it's not the native VLAN. If it's the native VLAN, it will not get a tag, right? And if both switches have agreed on what the native VLAN is, and again, I'm jumping ahead, if they've agreed what the native VLAN is, they know untagged traffic that isn't tagged is the native VLAN.
Okay.
Make sense?
It does. I'd like to explore more on native VLAN, but I can wait for the next
Yeah,
session or whenever.
we're not there yet. And I don't want to go too early because what this book doesn't do is they don't talk about the concept of tagged and untagged in native VLANs. And I want to give you guys, I want to create outside because the book doesn't cover it. I'm going to give you guys my own breakdown in the course session on tagged and untagged and what that looks like.
Perfect.
Okay. I didn't know that. Of course, I took the CCNA, took all that, and I struggled with that whenever I worked my first engineering job. And I was like, dude, what's tagged, untagged? I don't know what that means. I knew what it means, but the terminology was different. And you not, and of course, DeMarco, I'm sure you can attest. I harp on people that come to me and say they want to do networking. I harp on terminology and studying so much, and I'm so passionate about it because you not knowing a terminology, a concept, a theory can be the reason why you either A, are not advancing your career, B, that your colleagues or maybe your superior doesn't trust you, or C, that it takes you long to troubleshoot something. So it's very important to read and lab as many times as you need to, depending on how you learn, to understand a theory and to be able to explain it at a moment's notice. Okay?
Mhm.
Any other questions, guys? That's just regarding what we went over.
No, I was gonna ask a question, but I can wait. It was just I was just looking at the tags on the VLAN tags. Just noticing it wasn't like a router or whatever, but I see it's a layer 2 switch, so it's just basically talking about that. But I'll wait till we get to layer 3.
Yeah. We'll get to that, right? We'll get to multi-layer switch and how um and how that works, right? I want you guys to get out of layer 3. I want you guys to just focus where we're at layer 2 because again, we're at part 3, which part 3 is implementing VLANs and STP. I want you guys to only focus on layer 2 at this moment. Read chapters 8, 9, and 10 20 times over
Gotcha.
because part 4 and part 5 and part 6 and part 7 of this book, part 4 IPv4 addressing, part 5 IPv4 routing, part 6 OSPF, part 7 IP version 6. I am telling you guys the speed that we're going to go, I'm just going to throw technical terms, and this is how the real world's going to be. But you have to understand concepts at layer 2 before we can go to layer 3.
Gotcha.
Okay?
Gotcha.
So if you don't understand, if you don't understand, and if I test you guys at a lot of things at layer 2, there's no reason why you should be reading anything at layer 3 at the moment.
Gotcha. That's understandable.
Okay? All right, guys. Good session. And I will see you guys on Sunday.
Perfect. Thank you.
All right, guys. Later.
Bye.